start out by asking you, Richard, in this conversation about what leads to a meaningful life, what was it like to look back over your life and to write about it?
It's rather humbling. You look back on your life and you think, why on earth would anybody want to know about this? And I never kept any diaries, and so it's all based on memory. And so it's a very selective thing. It's the things that happen to have stuck in memory, which I suppose is non-random. I suppose it's those things that are of most interest to me. Memory is fallible, however, and I was rather sobered to discover, I think, two glaring instances of false memory syndrome where I was actually able to demonstrate that I got things wrong. One was not terribly interesting. I was in Panama and celebrating, as I thought, a new decade. I thought it was January the 1st, 1980. And I distinctly remember drinking to the new decade, and it was all celebrating. I only later discovered it was actually January the 1st, 1981. And so I'd completely made up that memory in my head. But a much more interesting one. I was on a debate with Christopher Hitchens and Anthony Grayling, A.C. Grayling, against Rabbi Julia Neuberger and two other people. It was a kind of religion debate. And at one point, this is what I remembered, Rabbi Neuberger said something about you need religion to be moral. And Christopher Hitchens was sitting about as far away from me as Jane is, and he said, this is how I remember it, he said, "How dare you? How dare you?" But he never said it.
You wanted him to say it.
Well, no, I mean, the story, it's a very curious story. He did say something. The reason that I know that memory is false is that I found a YouTube video of the occasion. We kind of believe the camera doesn't lie in this case. He did say something. He interrupted her at one point, but it's not audible what he said. The moment when he said, "How dare you," was in response to a question from the audience, which happened, half an hour later. But what's really interesting is that I was having lunch with A.C. Grayling, who was our other partner, and he was sitting again a yard further that way. And I told him about this false memory thing. I thought he'd be interested. And his jaw dropped. And he said, "But I had exactly the same memory." So think about this. Two university professors both imagine it was not just a remark by Christopher Hitchens, but a murder, something really important, court of law. Two witnesses, both university professors, both swear on oath that they heard exactly the same thing. And then imagine counsel for the defense saying, "Your Honor, I wish to suggest that both these witnesses are suffering from false memory syndrome." The jury wouldn't buy that for one moment, but it's true. That's what happened. For me, it shakes my faith in eyewitness testimony. I think we all tend to value eyewitness testimony more than we should. Eyewitness testimony is not that reliable. That people tend to disrespect DNA evidence, and they probably should value that more than eyewitness testimony in the way that we don't. Sorry, that was rather a drawn-out anecdote. I think it's interesting about false memory syndrome. It's a real phenomenon, properly studied. It really does happen. Both those memories are absolutely vivid in my mind, and they're completely wrong. So disregard my memoirs entirely.
But they're a great read, even if they're fiction. So let's go back to your childhood, which you write about in very glowing terms. You grew up in Africa. Your father was a colonial administrator, sort of at the waning days of the British Empire. Tell us a little bit about that and what influence it had on your own love of the natural world. Your father was a botanist.
Yes, I mean, my father read botany at Oxford and was a lifelong naturalist, and I think it was always a disappointment to him and to his father, my grandfather, that I wasn't much of a naturalist. My interest in biology has always been rather more philosophical, rather than, I was never a bird watcher, I was never a flower collector. Like my father, I tell the anecdote in the book of how, having arrived back from Africa, my grandfather pointed to a bird on the bird table outside the window and said, "Do you know what that is?" And I was very timid and frightened, and I stammered, is it a chaffinch? And my grandfather said, "Good God, John, is that possible?" And it was a blue-tit. I was not a bird. Admittedly, neither chaffinches nor blue-tits occur in part of Africa where I was, and so it's not entirely fair. But I wasn't a naturalist, and I've more recently become interested in natural history, but I'm not the sort of person who can tell you what a bird is when you see it flash by. So my interest was always rather more philosophical. So Africa, although I lived there until I was nearly 8, and imbibed the sounds and the scents and the sights, it didn't turn me into a naturalist. I don't remember seeing elephants and giraffes and zebras and things like that.
So what gave you the appetite for wonder?
Well, science. I was always interested in science, but it was more the kind of Carl Sagan sort kind of looking up at the stars and being fascinated by that. Here in Aspen, I naturally gravitate to the Buckminster Fuller Dome, which I recommend. They're showing wonderful shows about the universe and about human dispersion around the world and things like that. So science has always intrigued me, and still does.
Yeah, I get a sense that you were taught to ask questions and be sceptical as a child. Is that true?
Yes, definitely. And I think I owe to my father, although I never learned natural history from him. I think I learned scientific questioning from him, yes.
Yeah. So you went to Oxford and read zoology.
Yes.
And you then became a research student. And in the first volume of the memoir, you talk a lot about some of the rather mathematical work you did pretty early on, before you wrote The Selfish Gene.
Yes.
And you also said you were, in the early days of computers, when they were as big as a room, you were a bit of a computer addict.
Yes.
Have you broken that addiction yet?
Yeah, sort of. I'm still, like everybody else in the room, I do the internet and things like that, but I've given up programming. I was addicted to computer programming from fairly early days, when it was much harder than it is now. It is a vice. It's a vice that you need to shake off unless you do it professionally. I did ridiculous things like, in order to write my third book, The Blind Watchmaker, I actually first wrote my own word processor in machine code. And that's a ridiculous thing to do. If you want to write a book, don't begin by writing your own word processor. But that shows the level of addiction that I'd reached. It was quite good, actually. It was called Scrivener, and it worked, and it was more advanced than the commercially available one. But nevertheless, I'd have got The Blind Watchmaker written a lot more quickly, but for that. So yes, I was an addict at computer programming, and I have shaken off that addiction, thankfully.
But can you talk a little bit about the mathematical element of your research before you wrote Selfish Gene?
Yes.
I didn't know about that until I read the book. It was very interesting.
Well, it was a kind of textbook example of Popperian setting up a model of something that you don't know, deducing predictions from it algebraically, and then testing the predictions. So the particular problem that I was talking about is a very mundane one, really. It was how does an animal make decisions between alternative choices? And so, one way to answer a question like that would be neurological, would actually be sort of go into the brain and study it that way. But I was intrigued by doing the equivalent of working out what's going on inside the black box, which is the skull. It was baby chicks that I was working on. Don't actually look inside the skull. Instead, imagine alternative hypotheses, alternative models of what might be going on. Deduce algebraically predictions that follow from these alternative models, and then do experiments to actually test the predictions. And it's important, for this to be interesting, it's important that the predictions that you deduce should be mathematically precise. It's not good enough to predict that a quantity X shall be greater than a quantity Y, because there's kind of a 50% chance of that being true anyway. You have to predict that the quantity X should be exactly, 3 times the square root of Y or something like that. That wasn't that actually, but it was equally precise. And then gather enormous quantities of data. The more data you get, the more the result should, ideally, the prediction should converge on the observed, and they did converge very, very exactly. So the prediction was very, very exactly fulfilled, which in a sort of Karl Popper world gives confidence in the model, in the hypothesis that you've suggested. And then, of course, you can speculate about possible neural mechanisms and also develop further developments of the model and then predict them. And so I had about 7 or 8 separate predictions, all quantitatively precise from various versions of this model. What it actually found out about baby chicks, and actually the members of the 4 leading symphony orchestras of the United States, I tested the predictions on them as well. What it actually told me about what's going on in their brains was probably not that interesting, but it probably was. I think it actually was rather a nice example from a philosophy of science point of view of how you can proceed without looking inside the black box.
So what then moves you to come to write about evolution and genes?
Well,
how did you get there?
Around the time, well, a little bit earlier actually, I wrote The Selfish Gene in 1975. Sometime during the 1960s and early 70s, there was a spate of books by people like Conrad Lawrence, Robert Ardrey, a spate of television documentaries, all of which were based upon a very appealing but fundamentally flawed view of the way evolution works, which is that natural selection works at the level of the group or the level of the species. And this error comes to a head when you're talking about animal altruism, about the evolution of cooperation, the evolution of the tendency for animals that fight to restrain the ferocity of their fighting. And the erroneous explanation is that groups or species in which animals are selfish go extinct, whereas groups or species in which they behave altruistically for the good of the group, cooperate for the good of the group, restrain their aggression for the good of the group, those groups survive. And so that's why we see altruism. That's just completely wrong. And I wanted to expose that. And so I went back to first principles of natural selection. What actually does survive or doesn't survive in a Darwinian world? When we say survival, when we say natural selection, what is selected? What actually survives? And if you look at first principles, which we understood ever since the 1930s, it is the gene which actually survives. The body doesn't survive, it dies after having reproduced. Reproduction is the name of the game, as Darwin, of course, understood perfectly well. And if you translate that phrase, reproduction is the name of the game, into what's actually going on the ground, it is that some genes survive and other genes don't survive. The ones that survive potentially survive for millions of years, tens of millions, hundreds of millions of years. So the difference between a good gene, a successful gene, and an unsuccessful gene really matters because it goes on through the generations. And the body, the individual body, is then seen as, I called it, a throwaway survival machine. It's just a temporary vehicle for the genes, which then get passed on, or don't get passed on, in the case of genes which are not very good at it. And good at it, of course, means good at building bodies, which are good at surviving and good at attracting a mate, good at building a nest, good at reproducing. So the body is a machine for propagating genes, and that's the way to explode the group selection fallacy. You go back to first principles and you say what really matters is the survival of the gene. The primary vehicle of the gene is the individual organism. You could, if you really try hard, construct a world in which the group was the vehicle of the genes, but it doesn't work very well. It's negligible in practice. So that was my goal in writing The Selfish Gene, was to explode the fallacy of Konrad Lorenz's On Aggression, Robert Ardrey's The Territorial Imperative, and so on.
So can you, I mean, because I know you're really interested in empathy, and I assume you're interested, therefore, in altruism. Can you relate your work to a pretty big field now in altruism and empathy? When I'm just thinking very briefly about someone like Frans de Waal's work on bonobos and empathy.
Yeah. Well, although my book, The Selfish Gene, is called The Selfish Gene, it's actually mostly about altruism.
Yeah.
And so the sort of brief summary would be that genes are selfish, and genes program individuals either to be selfish or altruistic, depending upon which is best for the welfare of the selfish gene. And so, from a Darwinian point of view, the kind of reason why animals might show altruism would be kinship. Not only your offspring, but also your grandchildren, your nephews and nieces, your brothers and sisters, etc., your cousins, all have a statistical probability of sharing the same genes, and that means genes for altruism as well. So if there is a gene which specifically makes an individual behave altruistically towards nephews and nieces, then because there is a 1/4 of a chance of the gene being shared with nephews and nieces, then that gene will be favored by natural selection if the cost of the altruism is sufficiently low compared to the benefit to the recipient, where sufficiently low is given by that ratio 1/4. It's a half in the case of offspring, a 1/4 in the case of grandchildren, an 1/8 in the case of first cousins, and so on. So this is the main explanation for the amazing feats of altruistic self-sacrifice that the social insects show, and that various mammals show as well, and various birds show. The other main Darwinian sort of altruism is reciprocation. You scratch my back, I'll scratch yours. And that works not only within species, but between species, even between kingdoms. The proper way to do this is by game theory. Non-zero-sum games where if you cooperate, both of you do better than if you're both selfish. So those two, and elaborations of them, those two Darwinian reasons for altruism are extremely powerful, and they explain a hell of a lot of animal behavior. When you come to human empathy, it is arguable that we've got a Darwinian problem, in that we seem to be more empathetic than you might expect on purely Darwinian grounds. Why do we give blood when we're not paid for it? Why do we donate to charity? Why do we care about animal welfare? Why, when we see somebody in great distress, why, when we see somebody weeping, do we want to go and comfort them? It's not good enough to say, these people are not your relatives. They're not going to be necessarily in a position to reciprocate. So we have a problem in explaining it. It's not that difficult to explain. You can say something like, in our ancestral past, we lived in small villages or small roving bands like baboons, where the individuals you were most likely to meet would have been your close relatives, or would have been individuals you're going to meet again and again throughout your life, and therefore you would be in a position to pay back favors. Natural selection, of course, does not build into brains a cognitive appreciation of what's best for your genes. Natural selection puts into brains rules of thumb, which in practice, in the natural situation, work to improve gene survival. So if our history was largely baboon-like, then the rule of thumb, be nice to everyone you know, would work. Be nice to everyone you meet would work. Because everyone you meet probably would be a close relative. Everyone you meet probably would be a potential reciprocator. So the rule of thumb would then show itself psychologically as empathy. It would be just as sexual lust. The ultimate function of that is, of course, reproduction, but it shows itself in the form of a strong psychological urge. And that strong psychological urge persists even when we know perfectly well we're not reproducing, we're on the pill or whatever it is. We still have sexual lust, even though the original Darwinian end has been destroyed by contraception. Similarly, the lust to be nice, the lust to be kind, the lust to sympathize, having been built into us in our evolutionary past, is still in our brains, and we feel it extremely strongly. We feel it, speaking for myself, as strongly as sexual lust. I mean, the feeling of pity for somebody who's in distress is an immensely strong emotion, just as is the feeling of sexual lust. And so I have no problem in explaining that. Now, you mentioned Frans de Waal. He's not here, is he, by any chance? I mean, he just doesn't understand what
I had a feeling you were going to say that. That's why I asked you.
I mean, if you think superficially, instead of thinking about selfish genes, if you simply say, are animals nice to each other? And he studies chimpanzees and bonobos, and they're very nice to each other. Sometimes they also eat it, and they also not eat, but they kill each other. He sees it as a sort of tussle between those people who advocate selfishness, which he thinks I am, and those people who advocate altruism. It's not like that at all. I mean, altruism is a very powerful phenomenon, which we explain in terms of selfish genes. So Frans kind of thinks that he's on the side of altruism and I'm on the side of selfishness. And it's just not like that. We're both trying to explain the facts, which are that there is a lot of altruism in the natural world and a lot of selfishness in the natural world. And the trick is to explain why you sometimes get selfishness and sometimes get altruism. And we can do that in terms of selfish genes. We don't have to set it up as a kind of tussle between altruism versus selfishness, with some scientists on the side of altruism and others on the side of selfishness. So that's my little spiel on Frans de Waal.
Well, I'm interested. I mean, you know, Adam Smith, the Enlightenment philosopher in the theory of moral sentiments, essentially does say that we naturally feel pity. So he got that right, I'm glad to say, according to Richard Dawkins. That's good. But can I switch a little bit to the art, because in my world of the arts and humanities, we explain things like empathy by talking about the ways in which when people read novels, for example, they identify with the characters in the novels. One historian has described novels in the 18th century, which emerged around about the time that someone like Adam Smith was writing, as humanitarian narratives, which strikes me as rather interesting. Yeah. So I know you're a great lover of both music and poetry. I think you're a novel reader too. Can you build on into your scientific explanations the role of the culture that we create as human beings? Well, let
me take up the point about empathy in novels. When you first asked me about empathy, you linked it to altruism, and so I answered it in those terms. Yes. But of course, another aspect of empathy is putting yourself in the position of another person.
In another's shoes.
In somebody else's shoes. And that's, of course, what good novels do. You know, they let you put yourself in the shoes of the characters in the novel, and you come to believe in the characters, and you come to love the characters, you come to mourn them when they die, and so on. So we have quite a different question to ask a Darwinian now, not why are people altruistic, but why do people empathize in the sense of putting themselves in others' shoes? And it's a very interesting thought that since we swim around in a sea of society, we humans, we're an immensely social species, and success, biological success, evolutionary success in human terms often means second-guessing what each other is going to do, possibly to outwit each other, because we're, to a large extent, competing with each other, competing for food or mates or whatever it is, or second-guessing what the other one will do if we're trying to acquire a mate, acquire food. All of our lives is dominated by social interaction, trying to work out what the other person is going to do. And so putting yourself in another person's shoes, becoming a good intuitive psychologist, could be one of the most important attributes, one of the most important faculties built into the human brain. The psychologist Nicholas Humphrey is one of those who've advocated this point of view. There are several others. I find it very persuasive. I mean, Humphrey even goes so far as to think this might be the origin of consciousness. I don't know whether I can follow him there. But the idea of being able to predict what another person will do by putting yourself in their shoes, what would it be like to be that other person? That's a powerful idea for why we have empathy in that sense.
And it can work, of course, not only for the good of the other person. It can, I mean, if you're a marketer, right, it's one of the things you do in order to try and create products that are going to sell, right?
Yes.
So it's not always in the service of the other person.
Well, you can be quite cynical about it, yes. I
Yeah.
mean, yes. Yeah.
Can we talk a little bit about your love of music and poetry?
Well, yes, I have a bit of a blank, a bit of a blind spot where visual art is concerned. I don't really
Do you
get
know why?
Not really, no. But I do love poetry.
Do you have a favourite painter? Can I just ask that before we talk about
Well,
music and poetry?
I wouldn't. I don't think I ought to answer that because it would be false pretenses. Okay. I mean, you know, I vaguely think I like Impressionists, but I don't really understand what painting's about. So,
okay. That's fair.
But I do have a deep love of poetry and music.
Yeah.
So I guess I make up for it there.
How did your love of poetry develop? And you know, who ranks as your favorite poet or favorite poets?
Oh, well, W.B. Yeats, despite his loopy views on sort of mysticism and things.
Yeah, he did have those views, Richard.
Yes, he did. I know. I love his language, and I can get sort of lost in that Celtic mythology as well. A.E. Housman, Melancholy, Shropshire Lad. I think I got that from my father. Rupert Brooke, Shakespeare, Keats. My parents, I discovered this, that when they were engaged, my father was in Cambridge, and he would send my mother poems sort of every week, and they bound them, just handwritten, he just copied them out. And this little personal anthology that they developed together survives, and I often read it, and I learned a lot of the poems from the anthology that my parents put together. So there's a lot of Rupert Brooke, a lot of A. Housman, a lot of W.B. Yeats, G.K. Chesterton, Kipling. I get quite lachrymose. I mean, if you try to get me to read poetry aloud, I sometimes start crying. It's very embarrassing.
I believe you have just been reciting a poem this morning.
Yes.
Would you like to talk about that?
Well, Lisa New, who's a scholar of English literature, is compiling I think it's a sort of documentary film on poetry. It's mostly American poetry, and getting people to read a poem, and then she talks about it. And she got me to read the one poem that every American knows, which is Robert Frost's The Road Not Taken. I was a bit embarrassed because it is such a ubiquitous part of American culture.
It's all right.
But I read it, and then we talked about a view that I have, which I think is almost obvious, but which is kind of counterintuitive, which is that not just the road that we take as individuals, but the road that was taken at any moment in history has totally changed the entire course of history.
Yes.
And in one of my books, two of my books, I think, I've raised the hypothetical case of a dinosaur happening to sneeze. A particular dinosaur happened to sneeze at a particular moment, thereby failed to catch the ancestor of all the mammals. But for that sneeze, none of us be here. But then I've made the point, of course, which is one that a lot of people make, which is that each one of us owes our existence to the fantastically improbable moment of conception when a particular sperm out of millions happened to hit a particular egg. So then I quoted from memory another poem by Aldous Huxley, which makes exactly that point.
Would you like to quote it now, or not?
I don't mind. I mean, if you want me to.
Would you like a poem? Yeah. Okay, go for it.
A million spermatozoa, all of them alive. Out of their cataclysm, but one poor Noah dare hope to survive. And of that billion minus one might have chanced to be Shakespeare, another Newton, a new Donne. But the one was me. Shame to have ousted your betters thus, taking ark while the others remained outside. Better for all of us, froward homunculus, if you'd quietly died.
So I'm going to just suggest that you do have a favourite painter, and it's your wife, Lalla Ward.
Oh, okay.
And
How silly of me.
I'll just remind Lalla that I was the person who reminded Richard of that. But because I want to talk about Richard's tie, which was painted by Lalla, and he has a whole series of them. And talk about this one, and then I'm going to get you to talk about another one.
This is, she paints, all the ties are animals. This is a clouded leopard, and it lives in Burma. And we went to Burma last Christmas, and so she painted this for my Christmas present. The previous Christmas we went to Antarctica, so she painted penguins. And I've got zebras, warthogs, lots of other things, antelopes. I'll think of some more.
Okay, but the key thing is that when he was having lunch with the Queen, Her
The way
Majesty
one
the
does.
Queen,
Yeah.
the way Richard Dawkins does, he wore the warthog's tie, and maybe you'd like to tell that story.
This was a very curious thing. The Queen at that time had a weekly lunch where she invited a sort of fairly motley collection of people. I had the Australian rugby captain, a leading ballerina, Britain's leading Muslim, various other people, and we found a certain amount in common. But the Queen, though very charming, took exception to my tie. It was the warthog tie, and she took one look at the tie and said, I won't try to imitate her, it would be disrespectful. She said, why do you have such ugly animals on your tie? I was a bit taken aback, but in the spur of the moment, all I could think to say was, ma'am, if the animals are ugly, how much greater is the artistry to make such a beautiful tie?
So Lalla needs to paint a corgi tie. Corgis are the Queen's favourite dogs.
Yes,
and then that
would
will
be
meet
good.
with total approval.
Before ties, she did silk scarves. And beautiful, beautiful silk scarves were using the technique where the paint kind of runs into each other to make a kind of blotting paper effect, and really gorgeous ties. And at the time, she was trying to raise money, still is trying to raise money, actually, for the home for old actors. She used to be an actor. The home for old actors when they can no longer remember their lines. And she is the chairman of the trustees of this home, and she was trying to raise money. So we met Miriam Rothschild, who's a very lovely old woman, a distinguished scientist and a member of the extremely rich Rothschild family. So I encouraged Lalla to paint a scarf for Miriam Rothschild. And it happens that she's the world expert on fleas. So I encouraged Lalla to paint an enormous silk scarf with 9 species of flea on it, which she did. And I sent it off to Miriam Rothschild with a covering note and asking for a donation. And eventually a letter came back with a generous check. And she said, thank your wife for the handkerchief, but inform her that, as you no doubt know, she has not done justice to the penis of the male flea, which, as you know, is among the largest in the animal kingdom. And then she also sent a book which she had written, the microanatomy of fleas, inscribed to Lalla, which said, see page 143 for vagina of mole flea.
Okay, from fleas to music. You love music.
Yes.
And you have the capacity you have a very good ear, yes?
Well, I've got a good ear for melody. I can't do harmony.
Okay.
But one of the reasons why I'm very bad at playing instruments is that I have a sufficiently good melodic ear that if I can whistle a tune, I can play it on an instrument. So it's almost as automatic as whistling, which meant that when I was supposed to be learning to read music, I was just playing by ear all the time. And so I never really bothered to learn to read music, much to my regret now. But so I just kind of tootled, and I'll tootle on any instrument you give me and produce a tune. But it's a skill that should not be encouraged, really, because it makes you lazy.
Do you like to sing?
Well, I was in the choir at school. I was a treble in the choir at school, and I loved singing the anthems. And when my voice broke, I can still sing in tune, but it doesn't sound very nice. So don't ask me to sing.
Okay, I won't. But I do think I want to be clear. This was the chapel choir at school. You were singing
yeah.
anthems for religious services, just so we all know.
Yeah. I love those anthems, still do.
And you belong in a whole category of people. Philip Pullman, the novelist, the wonderful novelist, belongs in the same category of being sort of still loving the Anglican choral tradition, really.
Yes, I call myself a cultural Anglican.
Yeah.
That's really what you are, Jane, you know.
I know you think that, yeah. That's why we just agree too much. So we'll move swiftly along to being one of the most important writers of science. Not a popular, I don't want to call you a popular science writer. I want to call you a real scientist, a research scientist who has managed to write about science in a way that's accessible to people who are not scientists, such as myself. And that's an extraordinary gift. Can you talk a bit about that?
Yes. I was given a named professorship, the Charles Simonyi Professorship of the Public Understanding of Science at Oxford. And Charles Simonyi, who was the benefactor and one of the Microsoft billionaires, wrote a beautiful manifesto to Oxford when he endowed this chair, in which he magnificently said, I don't wish to tie this benefaction up with red tape. This is for the public understanding of science, but it's an endowment in perpetuity, which means that this will go on for centuries. And I don't want to have a lot of lawyers coming in and saying this is how it's got to be, because I recognize that in future, the way the Oxford of the future will interpret the public understanding of science will be different. So he says, this is my intention now, in 1995. Depart from it in future if you must, but be aware of what you're departing from. And one of the things he said in the manifesto was he made this distinction, Jane, you've just made, between popularizing science as a journalist, say, writing about science, reading up about a scientific subject and then popularizing it, and scientists taking time off from doing their science in order to write about it. And he wanted to endow his professorship for the latter. I think it is an interesting distinction. I would like to see more scientists writing about their subject, not actually only for lay people, but for each other. I think that there's too much obscurity in scientific writing. There's too much using language which only a tiny minority of fellow scientists can understand. And I would like more scientists to imagine an audience looking over their shoulder as they write, which consists not only of the half dozen other people in the field, but broaden it out, at least to other scientists, and preferably to non-scientists as well. This is harder to do for some subjects than others, obviously. I mean, modern physics is extremely difficult. But for my kind of biology, it really ought to be possible to write it in such a way that it's far more widely understood than many people do. I like to think that at least some of my books have changed the way my fellow scientists think, while being written primarily with a lay audience in mind, that people actually working in the field, people working in the Serengeti National Park or in Antarctica on animals, actually have changed the way they think. They now think more in terms of what's this animal doing to maximize its genetic survival. And I like to take a little bit of credit for that.
So, I mean, you're a very beautiful writer, which is not always true of all scientists, and you write about science as the poetry of reality, and you I think, reflect that in your prose, so it's a pleasure to read you. How has doing that kind of writing about science given meaning to your life?
I'm not sure about meaning to my life. I think if you ask me what gives my life meaning, I suppose that an important part of it is science.
Yes.
But it's not just the practice of science. It's not going into the lab.
Yeah.
I was once at a conference where there were a lot of Nobel Prize winners there, and it was about the creative process in science, and they were asked, well, Hans Krebs, the great biochemist, was asked, how do you, what's your recipe for getting a Nobel Prize in science? And he said, go into the lab every day from 9 to 5 for 40 years. Well, I don't think that's right, but how did I get into that?
Well, just
meaning
of life.
That's right. I mean, the practice of science, the practice of going into a lab, that's not what gives my life meaning. It's more the Carl Sagan thing. It's more the feeling of exhilaration that I find myself in a complicated world, which is sufficiently complicated that things like me and things like all of us can exist. Things like us which are capable, which are sufficiently complicated to actually understand how we got here. I mean, that's a mind-blowing thought, that the processes of physics, the blind, unguided processes of physics, working through this remarkable processes of biology and natural selection and physiology and things, have given rise to brains which are big enough and complicated enough to understand the process of how they got here. I mean, isn't that a marvelous thought? Isn't that I'm lost for words. To think that here we are, capable of looking up at the stars, capable of looking down a microscope, and of appreciating the process that got us here. I mean, that gives your life meaning, doesn't it? I mean, could you imagine, once you realize that, it's hard to imagine wanting to do anything else, really, other than try to understand. No, there are other things I like doing too, of course. But I think I'm struggling, as you can tell, but you asked me about what gives my life meaning, and I think science does. And then the writing, having grasped this exciting fact, how can you at least not wish to convey it to other people to the utmost of your ability? And I think that's what drives me to write.
I mean, for some people, the very process of writing helps them explain the world to themselves.
Yes.
Right? So is that true for
you? Definitely, yes.
So you become clearer in the writing?
You become clearer in the writing, and I suspect that if you write for a more general audience than the specialist one, you find that you've explained it to yourself better as well.
Because you have to begin by asking a very large question and answering it in a way that is going to be understandable to a large audience.
And you have to step back and say what is necessary to understand before you can understand what I'm about to explain to you. Yeah. And that's a good step to understanding yourself.
So let's talk about the day-to-day thing of writing. What do you do? Do you get up early? Do you drink lots of cups of tea? Do you pace around the garden? What is it writing for Richard Dawkins?
I don't have a very settled routine. Okay. And I go in bursts, I go in fits and starts. I have long periods when I don't seem to get anything much done, and then I have a frenetic period of activity when I get a lot done. The process, I write on a computer. I used to write on a typewriter before I had a computer. I can't imagine doing that now, because the typescript of my first book, The Selfish Gene, was a complete mess of taped on bits of paper and crossings out and arrows and bits of sellotape and what do you call it here, Scotch tape. It's impossible to get a run at what you've been writing. Nowadays, what comes up on the computer screen doesn't have any messy crossings out or anything. It's a sort of word perfect. No, it's not word perfect, but it's text perfect. And you can read it and you can see the flaws in it. And so I find that my writing is subject to a kind of Darwinian process of natural selection. Every time you read it through, things change. You naturally select the prose by reading it through. And it's even more interesting than that, because I find that willy-nilly, without really consciously doing this, I find myself reading it through the eyes of a particular person who I'm imagining reading it. I imagine it looking over my shoulder. It could be, it could be anybody. It could be somebody I've just had a letter from that morning, so she's in my mind. And so I imagine, when I'm reading through the current chapter I'm working on, I imagine her reading it. And I say, oh, she wouldn't like that, or she wouldn't understand that, or I need to anticipate something there because she would wish me to do so. And so by the time I've been through it through her eyes, it's changed, and it's changed for the better. And so it goes through a sort of successive series of winnowings, which I think improves it.
So you have imagined readers. Can you talk a little bit about the role of the imagination in that writing about science? Because I think there are moments where you do call upon the reader to imagine certain hypotheses and scenarios in order to help them understand things.
Definitely, yes. I think it's an enormously important part, not just of communicating science, but of doing science. I mean, I mentioned Karl Popper a moment ago, and it's a big part of his philosophy of science. Yes, I mean, it's enormously important, and if you look at the titles of my books, many of them are metaphors, and the selfish gene itself is the blind watchmaker. You know, it comes from William Paley, the idea of, if you find a watch, and you examine it and you see that it's got lots of cogwheels and springs and things, it must have been designed. And so, as Paley said, how much more is that true of something like an eye? Well, now we know, of course, that things like eyes have come about by a sort of pseudo-design process, which is natural selection. The blind watchmaker, it's blind in the sense that it doesn't have, it's not deliberately planned, but it's also blind in an interesting sense that it has no foresight. So human designers actually look to the future and actually could anticipate what might happen in the future. That's the one thing natural selection never does. It only maximizes short-term survival. So the watchmaker of nature is blind in two senses. Climbing Mount Improbable. The idea that evolving something like an eye, if you think of it as being a design, a very, very beautiful design of a camera with a focusing lens, with three-color coding in the retina, with an iris diaphragm opening and shutting. If you imagine the improbability, the statistical improbability of that coming about by sheer chance, it couldn't happen. It's far too improbable. That's equivalent to jumping from the bottom to the top of a sheer cliff, climbing the mountain by leaping from the bottom to the top. It can't be done. But round the back of Mount Improbable is a gentle slope. If you go around the back of Mount Improbable, you just walk step by step up this gentle slope till you get to the top. The eye evolved by slow, gradual, incremental steps. Half an eye is better than, well, 50% of an eye is better than 49% of an eye. I mean, there's a gradation all the way up. So that's Mount Improbable. Climbing Mount Improbable is the metaphorical, imaginative title of the book. So I use metaphors a great deal, and I hope they help.
Yeah. So what do you want to do next? You've finished the two memoirs.
I rather like natural selection. I don't look very far ahead. I don't have another book in mind at the moment. One possibility would be another anthology of essays. I published one in, I think, 2004 called A Devil's Chaplain, and I might do another one of those. I thought about doing a child's version of The God Delusion. My publisher's not keen on that.
I can see why.
But no, I have not started another book, and I don't know, but I probably will.
So what are the everyday things that give your life meaning? The small things.
Well, nature. Although I never was a naturalist, I get great pleasure from the natural world, wildlife. don't know whether I should. No, I don't know.
The rest is too embarrassing.
Yes, yes.
So let's end with large questions. What do you think? Well, I have two big questions, really. I mean, one I think is about whether you have something to say about the role of technology as we go forward, and the other really is what you think the greatest challenge facing the planet is. And you could choose to answer one or both.
One might solve the other, I suppose.
Or might not. I mean, I'm there in Silicon Valley, where we think technology will solve everything, but I'm not so sure.
I love Silicon Valley.
Me too, I work there.
Yes. You do get a feeling of great hope and somehow forward-looking, driving ambition in Silicon Valley. There's no doubt that digital technology is dominating our world to a huge extent, and I think it does offer great hope. It's an interesting parallel to modern biology, modern genetics, which has become digital entirely. Yeah. This is something that Darwin could have had no idea about, the extent to which modern biology has become a branch of information technology. The DNA code, which underlies everything in life, is a digital code. It happens not to be binary, it's quaternary, but apart from that, modern genetics could just be the same. You could open a volume of information technology, computer science, and it's all the same kind of thing. And with hindsight, I think we could probably say that evolution couldn't have worked but for genetics being digital, high fidelity digital code. But that's a judgment with hindsight. Digital technology is leaping ahead, leaps and bounds. Moore's law is still holding true. Computer power increases by, I forget what it is, 1.5. I mean, who knows what Moore's law is? It double every 18 months or something of that sort. And there's a similar Moore's law that you can construct for genetic sequencing as well. It's a slightly longer doubling time, but it's there. I think it does offer great hope because as computers get cheaper, more widely available, that means that information becomes available all over the world to peoples who have been shielded from information for a long time and have been kept in effective darkness. So I have great hopes for the future based upon computer power. The greatest challenge facing us, I suppose I just have to trot out the cliche of climate change, which I think is immensely important and dangerously needs something to be done about it.
And because it's such an immediate problem, it seems to me.
Yes, yeah.
Okay, final question. I think I know the answer to this, but what is your favourite book?
Gosh, my favourite book. I'm not going to say The Origin of Species.
Okay, I thought he might.
Yeah. I think the collected works of P.G. Wodehouse.
Okay. So I urge you all in September, when the book is published, to read the wonderful second volume of Richard's memoirs. But for the moment, I just want to thank you all for being here, and most especially thank Richard for his life and talking about it.